recesses of the subcommittee at any time. Welcome to today's hearing entitled A Review of the Nuclear Regulatory Commission's Licensing Process. And I recognize myself for 5 minutes for an opening statement. Good morning, Chairman Burns. Welcome. Welcome to this hearing on the Nuclear Regulatory Commission's licensing process as it relates to the Department of Energy's nuclear R&D programs. Today we're going to hear from the Honorable Stephen Burns, Chairman of the U.S. Nuclear Regulatory Commission, NRC, regarding the extent to which the NRC and the DOE may actually cooperate to enable vital nuclear energy research. Chairman Burns, we're looking forward to your testimony. Over the next 5 minutes or so, I want to give you a quick overview of this subcommittee's previous hearings that have actually led us to hold this hearing today. Last December, we heard from a startup company and an environmental institution explaining that tech companies trying to develop the next generation of nuclear technology need greater regulatory certainty to raise capital in today's market. They suggested that the DOE should use its national labs as a forum to allow private developers to carry out this work. Interesting suggestion. In May, we heard from another tech company explaining that research infrastructure to provide versatile neutron irradiation capabilities is vital for universities and the next generation tech companies to research new materials and fuels. We also heard from the director of DOE's Nuclear Energy Innovation Hub that the increased capabilities to model and simulate nuclear reactions will allow researchers to eliminate assumptions, which can speed up and lower the cost to develop new technologies across the board. So, what does all this mean? I'll keep it simple. We have the best engineers in the world that want to take on commercial risk and develop these next generation technologies if we can just give them the opportunity. These new technologies can do 5 things. Number 1, mitigate proliferation risk, which is important. Number 2, increase fuel utilization. Number 3, reduce waste yields. Number 4, achieve higher safety margins. And number 5, reach even higher levels of thermal efficiency. The United States is at its best when we provide a clear path for our technology innovators to do what they do best, find creative solutions to the world's challenges. So now I'll explain what we intend to discuss in today's hearing. This committee has often found bipartisan support for the nation's open access user facilities that provide unique capabilities for both basic and applied R&D. This is a particularly good model because the users ultimately take on whatever form of commercial risk they so choose, while the government simply provides the infrastructure capability. The prospective DOE user facility we're considering today would be a fast reactor-based neutron source. As a practical matter, the construction of such a facility will almost certainly require some form of technical assistance from the NRC, and that will be an interesting topic to explore. Another issue, and perhaps the most challenging question for the subcommittee, is how can the federal government make the process simpler for entrepreneurs to conduct experiments that will enable them to translate theories for alternative reactor concepts into reality. The NRC has a regulatory process for non-power reactors, but the time required to issue a license appears to have created somewhat of a barrier to investment. So this raises a couple of important questions relevant to our discussion today. Number 1, can the DOE use its authority to host private developers to conduct novel experiments advancing next-generation nuclear technology? And number 2, could the NRC benefit in any way by allowing its staff to provide technical expertise and gain first-hand knowledge of such reactor experiments? It's important that we work together to find solutions to these challenges. America cannot and must not lag behind our global competitors in this area of critical technology. Again, we want to thank Chairman Burns for his testimony today, and we look forward to hearing from you on the NRC's role in advancing nuclear energy for our nation. I now recognize the ranking member, the gentleman from Florida, for an opening statement.
Thank you, Chairman Weber, for holding this hearing today, and thank you, Chairman Burns, for testifying this morning. The Nuclear Regulatory Commission has a vital role to play in ensuring the health and safety of the American people. The importance of this role in protecting health and the environment cannot be overstated. I look forward to learning more this morning about how the NRC is applying lessons learned during the Fukushima disaster in 2011 and lessons learned during the premature degradation of parts of the Saint Onofre nuclear generating station in 2012, as well as similar incidents and accidents around the world. Today we'll discuss new advanced nuclear technologies that address the safety, waste, and cost issues associated with previous generations of nuclear power plants. Given that the bulk of NRC's expertise and resources are focused on licensing and ensuring the safety of current light water reactors, the path for developing, commercializing, and licensing newer technologies is less clear. Should a breakthrough in nuclear fusion be achieved in the next decade, the path toward licensing a fusion reactor is to be determined. I look forward to working with you, Chairman Burns, to address these issues as they arise. New technologies have the potential to change the world's energy landscape radically. They have the potential to meet our energy needs while significantly reducing the threat of climate disruption. We must give these new energy options a chance to prove themselves while also ensuring that they're not compromising our health or our safety in any way. Chairman Burns, I look forward to hearing your testimony, and I yield back the balance of my time.
Thank you, Mr. Grayson. And I now recognize the chairman of the full committee, the gentleman from Texas, Mr. Smith.
Thank you, Mr. Chairman. Today's hearing will examine opportunities for advances in nuclear fission and fusion energy technologies. We will hear from the chairman of the U.S. Nuclear Regulatory Commission, Stephen Burns, who will provide the regulatory perspective on matters of policy for the next generation of nuclear energy technology. The Nuclear Regulatory Commission is an independent regulatory agency that licenses and regulates America's civilian nuclear material and technology. The NRC was established in 1974 when Congress separated the supportive nuclear research and development aspects of the Atomic Energy Commission from its regulatory side. Currently, the Department of Energy supports nuclear R&D to advance nuclear science, while the NRC licenses new technologies as the private sector brings them to the market. Today we will get a better understanding of how DOE can more effectively advance innovation in nuclear energy and align its R&D priorities to fill gaps where the NRC is not permitted to do so. Nuclear energy provides reliable, zero-emission power. This technology represents a great opportunity for innovation to increase our nation's economic prosperity and global competitiveness. Yet the status quo is not working to bring new reactor concepts to the market. One challenge is that the NRC's licensing mechanism for alternative reactor concepts is not yet fully developed. This is not necessarily a fault of the NRC, as it must first oversee the safety of its licensees, which fund 90% of the Commission's budget. The NRC's strict mission focus has helped the U.S. nuclear industry attain one of the safest working environments in the world. The Committee's responsibility, however, is to look beyond today. We must search for opportunities where our nation's R&D can help make our future brighter. The DOE national laboratories provide vital capabilities for the private sector to invest in innovative energy technologies. This includes its open access user facilities, which are one-of-a-kind machines that allow researchers to investigate fundamental scientific questions. These facilities enable a wide array of researchers from academia, defense, and the private sector to develop new technologies without favoring one type of design. This represents a better approach than simply picking winners and losers through energy subsidies. DOE's labs also provide the fundamental research capabilities that lead to scientific publications or proprietary research. For nuclear energy R&D, this research is especially challenging because of the inherent regulatory burden that comes with using nuclear material. For this reason, the DOE and NRC should cooperate where appropriate to ensure that the R&D investments we make today will reach the market for the benefit of all Americans tomorrow. Thank you, Mr. Chairman. Yield back.
Thank you, Chairman. Our witness today is the Honorable Stephen Burns, Chairman of the U.S. Nuclear Regulatory Commission. Mr. Burns served as General Counsel of the NRC from May 2009 until April 2012, after having served as the NRC's Deputy General Counsel from 1998. Mr. Burns received his bachelor's degree in German and history, magna cum laude, from Colgate University and his JD from George Washington University. Mr. Burns, you're now recognized for 5 minutes.
I appreciate the opportunity to appear before you today to discuss the NRC's licensing policies as they might apply to current and prospective Department of Energy nuclear energy research and development programs. In January, the NRC marked its 40th anniversary as the independent agency in the United States responsible for licensing and regulating civilian uses of radioactive materials and nuclear facilities. To ensure the protection of public health and safety, the common defense and security, and the environment. The NRC's regulatory program has been substantially strengthened over the years, based in part on what we have learned from both domestic as well as international operating experience. Staff has made significant progress in preparing to review design certification applications for small modular reactors, one of which is expected to be submitted in late 2015. And finally, the NRC is taking initial steps to prepare for the review and licensing of non-light water reactor designs, which are the subject and focus of today's hearing. Our cooperation with the Department of Energy on topics of mutual interest dates back to the Energy Reorganization Act of 1974, when the old Atomic Energy Commission was split into two separate organizations, the Energy Research and Development Administration, which later became part of the Department of Energy, and the NRC. The skills and experience base of NRC and DOE are highly complementary. The mandate to conduct R&D programs, including civilian nuclear energy research, development, and demonstration, ensures that the Department of Energy has a deep technical capacity in a wide range of nuclear technologies. The NRC, as an independent body, focuses on licensing and oversight of commercial nuclear power operations to ensure public health and safety. The mutually beneficial relationship across the nuclear plant life cycle pays dividends to both agencies. DOE has been a key technical partner as the NRC moves toward gaining expertise in non-light water technologies and looks to adapt its licensing framework. The statutory authorities governing cooperation between NRC and DOE are well established. Our role in a project located at a DOE site is shaped by the purposes and function of the proposed project. Depending on the specific goal and purpose of the project, NRC could have licensing and regulatory authority over some types of facilities that are envisioned, for example, in H.R. 1158. For example, the Atomic Energy Act currently authorizes the NRC to issue licenses for production and utilization facilities for commercial purposes or licenses for research development purposes. The NRC has substantial experience in reactor licensing, with licensing processes that are well established and which have been applied to an array of reactor technologies. We've determined that our current reactor design licensing regulations are adequate for conducting reviews of advanced reactor applications. However, we recognize the potential gaps in understanding of acceptance criteria for both NRC staff and applicants. To better understand the opportunities for most efficiently adapting the current regulatory framework for non-light water reactors, the agency has reviewed our licensing processes and infrastructures. We had a report in 2012 to the Congress on advanced reactor licensing, and it included such recommendations as the need for additional research in areas such as materials and structural analysis, the need for appropriate computational tools for use in application reviews, and ensuring that appropriately trained and experienced staff are able to perform the reviews. We'll continue to develop our capability to evaluate non-light water designs that may proceed to commercial maturity at a pace consistent with appropriated resources and congressional direction. We don't favor one particular technology over another, but through open communication with the non-light water community and developers and with the DOE, we're able to better optimize our planning and resources to conduct licensing reviews when a complete and technically sufficient application is presented for our consideration. We'll continue to work closely with DOE within our respective legal mandates to look for additional joint opportunities to make overall reactor development and licensing processes as transparent and as navigable as possible to reactor designers and potential applicants. In fact, we plan to hold a series of public workshops with the DOE starting this September to engage further with designers, applicants, industry groups, and the public. In closing, I'll note that the NRC remains a technically adept and widely respected independent regulator domestically and internationally, and drawing on our experience and licensing processes that protect public health and safety, we've taken a number of steps to prepare ourselves for the future. While we also recognize the important and complementary role the DOE plays. Thank you for the opportunity to appear before the subcommittee today, and I look forward to your questions. Thank you.
Thank you, Chairman Burns. You said the NRC was 40 years old in 1975.
Yes, we came into existence at the beginning of 1975.
January 1975.
We have a 40th birthday this year.
Well, you don't look that old. I just want to... Interestingly enough, on this day in history, in 1957, the IAEA was formed. So it's a very apropos date for us to have this testimony. Chairman Burns, I'm recognizing myself for 5 minutes for questions. Chairman Burns, I believe you said that the NRC would not have jurisdiction over a DOE-owned and operated user facility, such as the proposed fast reactor-based neutron source under consideration in this committee. That said, if the DOE is to build this prospective facility under its own authority, my notes here say it may require technical review from the NRC, and of course, we believe that it would. And can you elaborate on the extent to which the NRC would be able to provide that technical assistance to the DOE for such a project as this?
Certainly. As you say, with the assumption that it's a DOE facility or created and constructed on behalf of the Department of Energy, we're still able to provide technical assistance and support to the department. It would be similar to what we do in the naval reactors area. We provide naval reactors reviews of new submarine reactor designs, or not only submarines, I think more recently aircraft carrier design. So under basically reimbursable agreements, we will look at those technologies and can provide that kind of assistance. It also, in some respects, can benefit us to the extent that in the future we may have similar type technology come before us. In our own licensing role, we can gain experience that way.
Well, you would be on the cutting edge, or the leading edge, as it were, of watching that kind of technology develop. You pointed out that if data collected from this facility is used to make the safety case in a future license application, the NRC would need to ensure that its quality assurance program is followed. It makes sense to me that you would need to independently verify data if it's used to prove the safety for a product once it's commercial. So my question is this: could this potential facility be helpful to the Commission for that very purpose, for verifying that physical data?
I think it could be. And again, I think the point I was trying to make in the testimony was that when you do the evaluations and the testing, and the department would be doing it at a high quality level. I don't mean to cast any aspersion, but again, if you're looking for transferability from the department's context and then ultimately to, say, a commercial context, the more you have conformity or harmony between the two organizations, the more useful, I think, in the long term, the outcomes or the information you glean will be.
In layman's terms, if you actually watch that process unfold, understand the steps it took to get there and the verifiability of that data, then that would actually help the NRC in its role, wouldn't it?
Yes, it's not only the being able to observe, understand, or see the results, but it's also the processes through which the results are obtained.
Sure. You explained in your opening testimony, Chairman Burns, that the NRC's role in a project at a DOE site would rest on the purpose and function of the proposed project. So if I understand your testimony correctly, DOE may enable private developers to construct and operate research-oriented reactors for purposes such as proving concepts by reducing theory to reality, provided two things are true. Number one, DOE would in fact have to own that experimental reactor, and number two, that experimental reactor may not be used as a basis for commercial power technologies. Can you explain how you arrive at the conclusion that if the experimental reactor itself cannot be privately owned, even if its purpose is solely to improve new technology and increase practical knowledge at a DOE site?
I think, again, I'm hoping to make this clear. Again, if the project is on behalf of or for the benefit of the Department of Energy within its authorities, it's not licensed by the NRC. To the extent if you had, I think maybe an example might help, if you had a private company essentially creating on a DOE site a commercial venture, that would be licensable by the NRC. That's what I'm intending to say.
Sure, I got you. Okay, well, I'm out of time here, so I'm going to yield to the gentleman from Florida.
Thank you. At two recent hearings held by the subcommittee, witnesses testified that the NRC's standard process for licensing a new commercial-scale nuclear reactor would be too costly and time-consuming for early-stage pre-commercial demonstrations of advanced reactor concepts to move forward. So let's start with the threshold question, which is whether those processes actually would apply in that situation.
Well, we have a licensing process that has been, well, in some forms has actually been in place since the earliest days of nuclear implementation of nuclear technology, even under the Atomic Energy Act. The NRC moved to what we call a one-step licensing, which is being used by some of the newer plants that are under construction today, about 25 years ago, which also provided for design certification. So we have the basic processes. I think the processes that can get through would apply and would work in these circumstances. I think where we need and where we're looking forward and talking with DOE as well is the areas in terms of where you're moving from light water technology to the advanced technologies, and how do our acceptance criteria fit that? Do you need exemptions from that? Are there other considerations? So that's the primary area where we've been focused, and I think trying to look forward, we need to focus.
Well, the criticism specifically was that the process would be too costly and time-consuming for these advanced reactor concepts even to move forward. Do you regard that as a criticism that's well taken or far-fetched?
I think probably I'm somewhere in the middle. Probably more on the notion. Again, the notion is I think we know how to license nuclear power plants in this country. Where we stand ready and able is to engage with potential developers who are interested in the new technologies to understand the issues they have, to understand, and so they also understand what they need to do in order to meet the safety requirements that the agency sets. And again, I think how that can happen is early engagement with the agency in terms of understanding what some of those issues are. So again, when I've looked at my understanding in terms of the application cost in terms of what it costs to go to the NRC is somewhere on the order of $45–70 million. That's the application fees. Now that's a small part of their development their development costs. What we can do, again, I think, is engage and assure that they're not off track or that they're on track in terms of the safety requirements that we require them to meet.
All right, so you addressed the cost element. Let's talk about the time element. These are capital-intensive projects. Mm-hmm. The money is borrowed in advance before any electricity or power is generated. There's interest payments in the meantime. What kind of time commitment are people looking at when they go ahead and seek a license like this?
Again, depending whether they're getting a license or they're certifying the design itself, which then can be referenced in other licenses. In both circumstances, I think, based on our consultation with the staff, we think we could do that on the order of 5 years. That's probably a little longer than our objective on current light water technologies, was more like about 3.5 years. But given that they're new, I think it's probably safer to say on the order of the 5 years.
You see any possibility of dramatically reducing either the cost or the time involved?
Well, again, I think as experience gains, I think the timing could be reduced. But there are, again, meeting or showing that you demonstrate conformance to the safety standards, also to go through the National Environmental Policy Act processes. I think for the current technology for new reactors, we set, I think it's about a 3.5-year goal.
All right, thank you, Mr. Chairman. I yield.
I thank the gentleman. The chair now recognizes the gentleman from California, Mr. Rohrbacher.
Thank you very much, Mr. Chairman. And could I ask you, how many employees does your agency have?
It's a little under 3,700 currently.
3,700. And these are highly skilled and educated people, I imagine.
Yeah, we have primarily a technical staff, and yes, very, very highly skilled in a number of engineering as well as scientific disciplines.
Okay, and what's your budget for annual budget?
The current budget is about $1 billion. I actually, over the next few years, I expect that to be smaller, in part because the number of new reactors that we originally anticipated, say 10 years ago, are not. The volume is not going to be there. So that's the primary reason I'd say we're going down.
Are your folks being paid enough to attract the type of high quality people you need?
Yes, I think so. We have, in terms of the civil service laws and provisions, we are able to pay well. We get good experts from that sometimes will have industry experience, but also academic experience, and I'm very proud of our staff.
You know, there's a lot of, especially on our side of the aisle, where we complain about bureaucracy. And let me just note that, I've used that joke myself, and bureaucracy is the most effective method known to man of turning pure energy into solid waste, all right? But I think that's really unfair of us who use these attacks of bureaucracy, because quite often it's not the bureaucracy, it's not the people, it's the system that is set up and the criteria that they have to work from. And I think it's very clear to all of us that we've got a problem in this country with the development of the next generation of nuclear energy. We are now we are involved with approving and putting into place nuclear reactors that are based on 65-year-old technology. Light water reactors are 65 years old, and they're dangerous. The environmental movement years ago, when we were first opposed nuclear reactors, were right in the sense that with this type of reactor, we have to deal with the waste problem and the potential of nuclear some radiation leaking from the system. Our newest systems, I guess, were sold to Japan, and look at the catastrophe that it's caused there. say, oh, this could never happen with these new light water reactors. Well, it did, because light water reactors are inherently dangerous. And some of us are dismayed. I am dismayed by the fact that we have not gone on to even produce the prototypes of the next generation. And there's something wrong with our system. There's something wrong with the way, what we have done to set up the methodology of bringing that new technology in. Your agency is playing a part in that, and I don't know, we have to change the system in a way that we can be the leaders in progress on this very important technology for mankind. Nuclear energy had so much promise, and now we know its dangers as well, but we know that there's possibilities of, I'm sorry, Mr. Chairman, I could go on for a while. I got some specific questions on this. Right now, do you believe that, look, I'm looking at thorium reactors, pebble-based reactors, high-temperature gas-cooled reactors, and even Lockheed even has a small fusion reactor. We have so many options, but yet none of them are moving forward into the market and being put to use. And instead, we're still improving light water reactors. Something is terribly wrong with the system.
Will the gentleman yield?
I certainly will.
That's why we're having this hearing today.
That's right.
I yield back.
And, well, let me just note, I would hope that we can try to restructure, that we have some positive things that we can come up with today, and working with you, not just today, but in the days ahead, to restructure this system so that so that the business community can commercialize, and can at least we can come up with, and the development community can come up with the prototypes that will give us a chance for future use of nuclear energy that's safe for our people. And thank you very much for holding this hearing, Mr. Chairman.
Thank the gentleman. The chair now recognizes the gentleman from Colorado, Mr. Perlmutter.
Thanks, Mr. Chair, and thanks to Mr. Rohrbacher. And honestly, this is an area where I'm new to this subject and new to this committee. So I'm going to have some very basic questions for you. My district includes Rocky Flats, where we produced a lot of plutonium triggers over the years. North of us, we have a mothballed, long time ago, plant called Fort St. Vrain. And so I'm coming at it from that point of view. So I'm going to ask just sort of basic question. How many nuclear plants do we have in the United States today?
Right now, we have 99 operating nuclear power plants in the U.S. I'd expect by the end of the year, early next year, 100th will come online. That's the TVA's Watts Bar 2. And there are, just to expand a little bit for your benefit, there are 4 other plants under construction in South Carolina, and 2 in South Carolina, 2 in Georgia currently.
And how many license applications do you have pending?
I might have to give you, for the record, I think we have on the order of about 7, but I might be, I might be off by 1 or 2 there. We have, for example, we recently authorized a license for DTE Electric near Detroit. We expect to have a hearing late this year on South Texas 3 and 4 in Texas, and there are a couple others as well.
How long would you say the average license application runs today? I mean, I know it has varied. Sometimes it's taken forever, and sometimes it's been quicker. What are they running today?
Well, again, what I think our objective is for the license, for the combined license for the new plants, is that we run about 3.5 years. So about 42 months. We have a required hearing.
Look, I just want the. I'm not condemning that. I remember.
No.
I have Rocky Flats. Okay.
Yeah.
I have legacy.
Oh yes.
I understand the public safety nature of the commission. So I'm not condemning that. I want you to do the right thing and do a good job.
Yeah. But that's what I'm saying. It's about a 42-month, a 3.5-year objective to complete the licensing on for a combined license that we issued now, that would assume that you have a certified design. So you take the design, say Westinghouse design, you reference it in the combined license.
Okay.
So it takes about that. Some of those, as you say, are longer.
Construction of a plant, how long does that usually run?
I'm trying to think. The current experience, I think, with the Vogel plant, it's been about. They've been under. It'll be about six to 8 years.
I mean, these are major.
Yeah, it's a major
construction.
And they've had some construction difficulties on the way, so they've been responsible about addressing those. So that's provided some delay.
All right, now to get towards Mr. Rohrbacher's question. So, can you tell me? And I know I'm a lawyer, you're a lawyer, and maybe you would want an engineer, but my guess is you know this. So, can you explain to me the difference between heavy water, light water, and some of the new technologies that he was just going through, thorium and gas plants and whatever?
All right. I'm going to be a little challenged on that, but basically the newer technologies, they reply. Say thorium is another would be used instead of uranium, for example, as a fuel. They may be cooled by different means. You have the molten salt reactor. You have the high temperature gas reactor. The technologies use different things. You know what? I would be pleased to have this technical staff sort of give you maybe a brief rundown or maybe a sort of shortened form on that.
Light water would.
I'll see you after work for a drink.
Okay. I'll see you down in the gym. Light water versus heavy water, and then I'll yield back.
Yeah, and the heavy water, for example, Canadians, the CANDU reactor use heavy water. It's again, it's the chemical characteristic of the water itself that's used. And they say I'm starting to get a little bit out of my
I'm happy
wheelhouse
to meet with you and anybody else.
Yeah.
That would be great. And I yield back to the chair. Thank you very much.
Boy, how would you like to be a fly on the wall in that meeting? The gentleman is from Illinois, Mr. Hultman, is now recognized for 5 minutes.
Thank you, Chairman. Thank you, Chairman Burns, for being here today. Nuclear energy is very important for my home state in Illinois. And with increasing burdensome regulatory regime being proposed by EPA, nuclear energy is still the only viable zero-emission-based load power source. With arbitrary caps that our states are being forced to implement, just maintaining our current fleet is vital to be able to hit these mandates. But there's more we can be doing to put America in a place to lead the world on the next generation of advanced reactors. Where our reactors go, our regulatory structure goes with them. We need to be aware of this, and we need to get a foothold in other nations if we'll be able to export these technologies in the future. For this to happen, we need a regulatory structure that seamlessly allows for the informed licensing of these facilities down the road. Chairman Burns, I appreciate your commentary on my legislation, and I do have some questions about where the line is drawn between the DOE and the NRC authority to regulate a facility. You said in your written testimony, and I quote, that NRC would not have regulatory authority over reactors located on DOE-owned facilities that are used for the purpose of collecting data for research, testing of materials, or testing of fuels, end quote. At the same time, you say you would have authority over a facility that is operated in a manner for the purpose of demonstrating the suitability for commercial application of a power generation facility. I wondered, where is the line drawn if we are researching new materials? Does it become NRC jurisdiction if they're just trying to proof of concept work for something down the road? At the early stage, we are certainly trying to establish the properties of new material and fuel, but when does NRC consider this research to be for commercial application?
I think. Thank you for the question. Again, we're probably at some of those sort of gray areas where the line is, and probably in looking, if we get to that, if we're getting to that point, I think that would benefit us, and I think also the department of understanding what the purposes of the project are. Again. The bright lines, as you say, it have to be if it's basically a DOE, a contractor to DOE for the benefit of DOE. I'm phrasing it that way because that's that's clearly on the DOE side. Again, where what I don't want to leave, I think, is the impression that any possibility that it may have ultimately translated into a commercial benefit down the line means necessarily that it's it's NRC's jurisdiction. That's where I think we have to look carefully what it is. Again, perhaps the easier example is if the demonstration plant DOE is providing the land for the demonstration plant, it is being hooked to the grid, and that type of aspect. That, I believe, would be our jurisdiction. I think what it is, this may be one of these things where we have to look at it carefully in order to give a complete answer, I think.
Okay. Well, if we can maybe follow up on that some more.
Sure.
There's concern there, and we want to make sure
that
we do that well. Let me move on. My time's going by fast. Does NRC consider things like the time value of money or opportunity costs of lost development in the U.S. When forming regulation?
Our regulatory scheme, based primarily on the Atomic Energy Act, says we need to establish it as a baseline adequate protection of public health and safety and common defense and security. And at that point, you have to reach that threshold. Above that threshold, we do, in effect, include cost-benefit analysis in terms of assessing whether above the minimum required for safety, is there a benefit? Is there a substantial additional safety benefit for additional things? So in that respect, beyond the base requirements, we would consider, in fact, costs and benefits of additional regulation.
Let me wrap up one last question. How does the NRC anticipate changes in technology so that a regulatory process can be responsive to innovation? And tied to that, does the NRC funding structure limit the Commission's ability to accommodate innovation?
The way we anticipate potential new design is staying in communication with Department of Energy. We have good cooperative relationship with the Department of Energy, but also hearing from potential designers and potential applicants. We encourage them to come and meet with us to lay out what their plans are, and hearing from the industry what their expectations are. And the second part of your question, I'm sorry, I forgot the second part of your question.
Well, it's my time's expired, so we can follow up maybe with
okay.
with written things. No, that's fine. Just was wondering about the NRC funding structure. Does it limit the Commission's ability to accommodate innovation? So it's 90% funded by licensees. Wondered if that limits Commission's ability to accommodate innovation. We may follow up with written questions if that's all right.
Okay.
With that, my time's expired, Chairman. I yield back. Thank you.
You actually have some time, Mr. Holtman, if you'd like to follow up on that second part of that question. So I think we're going to go for a second round of questioning here, if that's all right with the. You have any questions? You're good. Okay. Well, you're out of time. But no, you have time. If you want to follow up on that second, go ahead. Take time.
Why don't we just communicate with your office if that's all right? We'll get some written questions to you if you don't mind responding to those. We just want to get some clarification there and make sure, again, we're recognizing how innovation is so important, but also how regulation can either encourage innovation or hinder it. And we want to make sure that while we're doing everything to keep things safe, we're also doing everything to see potential advancement and taking a leadership role in the world. So thanks, Chairman. I'll yield back, but we will follow up with some written questions. Thank you.
I thank the gentleman. And I do have another question that I wanted to get answered, if I could, Mr. Burns, and that would be reading through the different requirement, the different powers, if you will, of the NRCC that's charged. Decommissioning was one of them. How many decommissioned plants do we have in the United States?
Well, we've completed decommission or oversight of decommissioning of a number of very early generation plants. I think currently there's something like 5. I think 5 are in decommissioning. There may be a few more than that.
Okay.
Currently.
And do you get involved with the Navy's decommissioning of their different vessels?
No, I don't believe so.
No. Okay. Recently, we had an older ship come to Galveston, where I represent, where they were dismantling it, and there was a lot of talk about that. So, okay. Well, just for the record, I appreciate y'all. I think that the idea of the NRC working with the DOE will give y'all a leg up on watching this new technology kind of unfold, as it were, and so that when you're involved in that process, it'll actually help. And with that, I'm going to recognize the gentleman from California. Oh, I'm sorry, the gentleman. Are you good? Okay. You don't want to violate the witness's rights anymore? Okay, good. The gentleman from California, Ms. Rohrbacher.
Thank you very much. Well, first, let me ask you, how long does when you approve a nuclear power plant, like we've been talking about, how long is that actually functioning? 10 years, 20 years, 30 years, 40 years?
Well, under the Atomic Energy Act, for a nuclear reactor, a license may be issued for an initial term of 40 years, and it can be renewed. We have about 75 of the current plants of the current fleet that have their licenses have been renewed. Once
they build a plant, how long is it in operation?
Well, it'd be much of the fleet has been or is approaching 40 years, and some of the plants have gone into the license renewal.
Let me know, Mr. Chairman, that I think it's outrageous then that we are approving any new light water reactors. If that means we're stuck with them for 40 years, and quite frankly, it's old technology that's dangerous, and for us to be putting Americans 40 years, future generations of Americans in that danger is absolutely ridiculous. And especially when we have a number of companies, people with good reputations, who tell us we can build a safe reactor, and we haven't been able to get through the system in order to build our prototypes that is a safe alternative. And so that being on record saying that, let me ask you this, and we've been told this. This is not about necessarily a policy, but maybe a mindset when these new reactor people are coming forward. They're saying that basically we're sort of in a vicious circle in dealing with this regulatory process, in that it's holding back significant improvements because and this is what they perceive, not necessarily a policy, but a mindset, that the NRC won't review an application without committed customers in the loop. So if they don't have someone already there saying we're going to finance this, then people don't take them seriously at the NRC, and if they're not taken seriously because they don't have, that just means the NRC is waiting for the customers, but the customers are waiting for the NRC because the people in the money world won't put the money up for something that hasn't been at least looked at and given initial approval by your organization. So we're sort of in, I guess, what you would call a catch-22. I remember Joseph Heller's book about this World War II pilot and all of the things he went through. Every time there was something to get done, there was a reason why you couldn't do this, but there was a reason you had to do it. So does that mindset exist? If it does, are we going to change that?
Well, Mr. Rohrbacher, what the obligation we have now is we're required to recover 90% of our appropriation through fees. And so basically somebody can come in, and I think that's some of their difficulty, is coming in, paying for the fee for the design review before they may have a customer or before they have sort of secure financing. That, I acknowledge on the other side that can be an issue for them, and I think that's part of what this committee is trying to explore. The other piece of it is it's really a question on priority of design reviews. because, again, as we have an appropriation, we don't have unlimited resources, so that if there isn't a customer for a particular design, that means it may not have a priority. But, for example, currently we have accepted the design. We do have a design certification under review, which there isn't a current customer in the United States. That's because we can again, they're willing to put up the fees, and we can accommodate within the current resources. So there may be ways to address that sort of go perhaps beyond what the NRC's
there's obviously a block somewhere when for 2 decades now I have been being told by people in the industry that we can create a safe alternative to the current type of nuclear reactor. And for 2 decades now, I've been seeing these people come to my office with really very brilliant people who've been involved in the nuclear industry, saying we can build these modular reactors in this way or that way or this way. And these are not fly-by-night people. These are very solid engineers, and yet they've made no progress towards even making a prototype. There's a fly in the ointment here, or there's a roadblock there somewhere. I think what we just discussed is part of it. Perhaps we need also to make sure that we are committed, not just in the NRC, but the Department of Energy as well, that we need to be committed as a country to getting this job done, to making sure we after a certain number of years, we're going to have a number of prototypes to choose from. And especially, let's not keep our people for 40 years in the future dependent on a dangerous source of electricity that could be replaced by something that's less dangerous. Thank you very much.
All right, thank the gentleman. I want to thank Chairman Burns for your valuable testimony and the members for their questions. The record will remain open for 2 weeks for additional comments and written questions from the members. Hearing is adjourned.